Hi, my wonderful students. We are now going to be tackling example 11, which example 11 is very similar to example 10. So if you felt like you understood example 10, I would definitely try this one on your own. Fast forward to the end and then see if you got it right. All right, you guys, let's get going. So, we are given that 5 times x plus 1 minus 4x equals 2x plus 5. And we're trying to prove, after we solve for x, that x will equal 11. All right, you guys, I'm already pumped up. Let's get started. All right, so if we think back to example 10, okay, what do we always do first in our proof? What do we always write first? Holy hot dog, you guys, you already knew. That's so exciting. All right, so you always write the given first. So that is going to be the first thing that we write in our proof. So I'm going to write the given first thing. Here we go. All right, and what was given to me, what I'm safely allowed to assume, is that 5 times x plus 1 minus 4x equals 2x plus 5. And my reason, well, I wrote that because it's what was given to me. So my reason would be the given. So given. All right, and from here, we're just going to solve this thing for x, and we're trying to prove that x equals 0. So let's see what happens. Okay. All right, so if you were going to be solving for x, what would you do first? Oh, man, I would do the same thing too, you guys. You would distribute the 5 first, which you don't have to do that first, but, you know, might as well get that part done with, right? So I'm going to distribute 5 to each term. So 5 times x will give me 5x, and 5 times 1 will give me a positive 5. And then I'm just going to bring everything else on down. Bring it on down. All right, and since I distributed the 5 to the x and the 1, what would be my reason? What did I do to get from here to here? I did distribute that thing. So this would be the distributed property. Distributed property. Lovely. All righty, let's keep going. I'm going to extend this because it's bothering me. It's not over. Okay. All right, after this, there's lots of things that you can do. What I personally like to do is to combine my like terms first. Do you guys spot any like terms in the problem? Oh man, I see them too, you guys. 5x and 4x are like terms. So I need to combine those things. So 5x minus 4x will give me a positive x or a 1x, whatever floats your boat. And then I'm going to bring everything on down. So I'm going to bring down the 5 and the 2x and the other 5. All right, now, when you combine like terms or add, subtract, multiply, and divide on only one side of your equation, do you remember what that is called? You guys always know the answer. You guys are so smart. You do simplify when you only add, subtract, multiply, and divide on one side of your equation. If you add, subtract, multiply, and divide on both sides of the equation, that's when you're going to be using either the addition, subtraction, multiplication, or division property. But since I only did it on one side of my equation, that means I am simplifying. So I'm going to write simplify. Got to say it all fancy like that. Simplify. All right. All right, guys, let's keep solving for x. So currently my x's are on separate sides of my equation. I want them to join together because they are best friends. They are besties. Okay, so I'm going to bring my x to the other side, which since x is a positive x, the way I'm going to move that thing to the other side is by subtracting it on both sides. Which x minus x will cancel and turn to 0. 2x minus x is x. So I'm left with 5 equals x plus 5. All right, I'm actually going to keep my colors the same because it's bothering you right now. You already know I didn't do that. that in this dark purple, so I'm going to keep it dark purple. All right, so since I subtracted x on both sides of the equation, what is that property called? It is called the subtraction property. Yay, subtraction property. Okay, let's keep going, you guys. So I'm really close to solving for x, but currently this 5 is getting in the way and it is irking me. How do you move a positive 5 to the other side? You would subtract it on both sides. You guys should teach me. You guys always know how to do these things. All right, 5 minus 5 will cancel and turn to 0. And 5 minus 5 will also cancel and turn to 0. So what I'm left with is 0 equals x. All right, now, and since I subtracted on both sides, which property did I use? Correct, like normal, you guys. It is the subtraction property again. You are allowed to use properties more than once. It's not like you can only use them one time and then you can never use them again. Okay, so this one is called the subtraction property. Subtraction property. All right, now technically it's telling me to prove that x equals 0. Well, I did prove that x equals 0 because 0 equals x. But proofs are really nitpicky, you guys. They want your final answer to look exactly like the proof. Which currently these two things mean the same thing, but they are definitely not written the same way. Okay, so I'm going to spin around my equation and I'm going to write my x on this side of the equation, my 0 on this side. Because when I do that, then my answer will look like the proof. If my answer doesn't look like the proof, technically you need to force it to look like the proof. Even if it doesn't want to be moved around, you still got to move it around. So I'm going to write x equals 0. Now, do you remember what that property is called when you flip around an equal sign or reverse it? You could also think of it this way. We originally had 0 equals x, and my new answer is x equals 0. So if you see here, when I flip my equation around, it kind of mirrors what I originally wrote on my paper, or it has symmetry with what I originally had on my paper. What is that property called that kind of has symmetry when you write the two things side by side? Oh man, you guys, you're correct. It is the symmetric property. So the symmetric property allows you to reverse an equation, or you can kind of think of it like it spins around the equal sign. So this is the symmetric property of equality, or the symmetric property. Oh man, you guys, does my answer equal what the proof is? Heavenly hamburger, it totally does, which means, you guys, we are done with the problem. And since we had a blast, I'm going to express my happiness with a smiley face because that's how I like to end my proofs. So nice job, you guys. You have tackled example 11. Way to go. We have done our first two proofs, which is very exciting. Nice job, you guys.